Hello there. Vector Podcast is here. And as you can see, I'm surrounded by several nice people here at Berlin Buzzwords 2022. And this is the reopening of Berlin Buzzwords after it was kind of like fully remote for a couple of years. So I'm really happy to be in person in Berlin and to meet all of the guys here. So we will start with Laura Ham from Semi. She has been working on Weaviate database, GraphQL, and many other things. How's it going, Laura, for you in the conference and in general?
Hi, good. Thanks. Thanks for having this podcast here. It's really nice to be here, meet people in person again, and meet you for the first time in person. So yeah, as you said, I'm Laura. I am working as machine learning product researcher at Summit Technologies, and at Semi we build the open source vector search engine Weaviate. So I'm happy to talk about that and talk about the conference with you.
Awesome. Cool to have you, Laura. We also have Florian Hönicke from Jina AI. So Florian, say a few words. How do you feel on the conference? And you're local in Berlin, right?
Yes, that's true. I like it a lot here. So they're well organized, everything, I guess. Already attended the keynote, which was quite interesting because it didn't just focus on the technical aspects, but also on the society we live at. And yeah, that's very, very much important that they put so much emphasis on this. And yeah, like ideally, we would continue talking with a lot of people here about neurosearch. And I think what Jina is building, like we solve a lot of these infrastructure problems a lot of companies have. And I think the only missing piece is that some companies didn't discover us. And I think would be very helpful for them using our open source framework.
Absolutely. And Vector Podcast is one way to get discovered, obviously. So great to have you here, Lauren. And we also have Etienne Dilocker, who is the co-founder and CTO of Semi, working on Weaviate, the engineer behind this whole thing. So how are you doing, Etienne?
Thanks. I'm doing great. Luckily, not the engineer anymore, but just one of the engineers, because they're not long ago I was the or one of the very few engineers. So yeah, super grateful to be here. Super cool. The first time for me at Berlin Buzzwords. Also in general, I think that's not the first time attending a conference at Semi, but yeah, with the pandemic, I think everyone is longing for just meeting each other in person. So this is a really cool opportunity, really cool conference. Yeah, first time here for me. I'm amazed by how professional everything is and how large everything is and the cool people you meet. So that's very cool. Dimitri and I, we didn't actually, I wasn't part of your podcast before. But yeah, other people from Semi have been, so it's super cool to meet you in person, have that opportunity here. Meeting Florian from Jina, I've seen Yo from Vespa walking around, haven't talked to him yet, but definitely on my agenda for today. So super cool to just like have these people that connect, I don't know, on Twitter and sort of on the space virtually every day, to see them everyone in the same place, or most of them in the same place. So that's super cool, super excited.
Yep. Thank you, Etienne, and great to have you as well. I think all of you are first timers on the podcast, and I'm really, really glad to have you here. I've been watching this space grow little by little, you know, and now we have like officially 7 vector databases, I think, on the market, and there are more cooking up, and like neural frameworks and libraries. How do you feel yourself being now part of this growing community?
Yeah, it's super great. So we see like there's a lot of movement right now, and of course, Weaviate is open source, but also the other solutions are most of them are open source, and I think that's really great for for the people who want to use it. And now that we're there, so we're not the only ones. So we see that there's also the market is growing for using such vector databases, and more use cases are opening up because we like together with the other solutions, we are opening up the vector solution space. So that's really exciting.
Florian, you want to say a few words on that front? Like, how do you feel as part of this community?
Yes, so some people might argue that's a very competitive market because a lot of companies doing very similar thing. But I would say it's just showing us we're going in the right direction, because if you tackle a market and you have no competitors, then you should maybe reconsider what direction you're going. So And I also like this like connection we built with each other. Like with Weaviate, for instance, we did this document array integration. This seems to work quite good. And yeah.
Yeah, really agreed, especially on the part about sort of competition being a good thing in that space, because as Florian just said, basically, if there wasn't any competition, then how could we be sure that we're doing the right thing? Like, why, if there's too much competition, okay, then why should you enter the market? But if there's not any, then is there really an audience for it? And I think we're really exactly in that time where the benefits of embedding search and also the downsides of embedding search and the ability to combine it with different things. This is all happening right now, and it's growing really fast. And something that we're currently seeing, which is what I really like, is that people are moving it into production. So we're getting like tickets in, like, hey, I'm using it in production and this happened, or these kind of things happen, which is of course not great that there are bug tickets, but I mean that's going to be the case with everything that's evolving. But it's super cool just to see that people are actually using it. Like, they're no longer in that phase. I mean, some people are in that phase of just discovering it and sort of discovering it at various levels in the stack. But there are some, and it's a growing portion of people that are moving it into production. And that for me is like a really, really good sign that someone made the switch. Like, okay, this is so useful for me that I want to take it to production. So that there must be value creation there, because they wouldn't take it otherwise. And yeah, it's super cool that users have choice as well. Like, I think everything is different. Every vector database, then of course we have that split. I think you said it right now, that the framework. So we have Jina, and also from Germany we have DeepSight's Haystack. So we have like two primary frameworks in the space. You can integrate them with various vector databases. You can integrate them with Weaviate, which you should do, but you can also choose other options. I think I'm not sure for DocArray. Like maybe that's a good one to hand to you. Like, what are the integrations for DocArray that you can use with various vector searches?
So to quickly summarize what DocArray is, like for researchers, scientists, they usually just have their data and would like to get started right away with just creating a vector search locally. So they don't need to host a live system and have tens of thousands of queries per second. So they just use the stock array, insert their data, and then run it locally to check what are their results and look at the evaluation. And if they would like to have a more scalable system, more scalable backend, then they would integrate with Weaviate, and they could create their their Weaviate backend, connect with a DocArray, and then have a scalable solution, just without any further change they have to do.
Yeah, I can just briefly add to that. It's really nice to see that. So we started with just a pure vector database. So Weaviate is it's really a vector database or a search engine, and it's really cool to see how this is now finding a place in the whole search field. So, for example, Jina's DocArray, or Jina in general, is a whole framework, end-to-end framework to build your whole search pipeline, with also training machine learning models, for example. And then now you can choose Weaviate as one of the document stores. So it's really cool how it finds also now a place in the existing and new technology.
Oh yeah, awesome. Actually, this year, Open Source Connections, which is one of the sponsors of Berlin Buzzwords conference, published a Search Insight report, and I happened to participate in one of the articles about vector search. And we kind of took a step back and we tried to describe this field and describe this approach to search, right? But of course, vector search does not apply only to search problems. So actually, I wanted to also invite you to step back and kind of open up this field. What traditional databases like SQL or NoSQL cannot do that vector search databases can? And also, like, what maybe if you can speak to use cases that you have seen with clients or some of the open source players implement that you cannot do also with traditional. For example, I can take Elasticsearch or OpenSearch and implement my search application, but some things are a little bit limited there, right? Even with all the machine learning, agendas and all the connectors and stuff, like in Apache Solr, you have OpenNLP framework. So can you a little bit open up on that front? Yeah.
Yeah, so what you see, like if we talk about data itself, we see that the traditional databases, like SQL databases, are usually working with structured data. And structured data is data that is saved in some like predefined format. So we have dates, like clearly defined dates, short strings maybe, numbers, those kind of things. Yeah, all kind of short data that you can put in a tabular format or in a relational database. But then on the other hand, we have unstructured data, and that's data that it's data that you find in the wild. So long text documents, images, videos, which you cannot easily store in such a traditional database. And then the next question becomes like, how do we search through it? Because in all these long text documents or images or videos, there's a lot of information hidden in this data. So the question becomes, how do we search through it? And of course, then we have a lot of machine learning models that can solve this problem. So not only by searching by keyword, but also like doing the semantic search because of machine learning. So that's there already, of course. So then the next problem is, how do we scale this? So how do we scale this to millions of data objects? And if you have many searches per second, you want to scale this for in production size, of course. And there you need a scalable database. And Weaviate or a vector database can solve this problem.
Yeah. So actually, this is a great segue to how do we scale things? Etienne, can you speak to that a little bit?
Yeah, of course. Just to quickly add to this in general, because a couple of keywords, sort of nice ideas popped into my head when you said them. So first one is with SQL databases. So something that we're currently also looking at into is like, can you use vector search, or it's more specifically Weaviate, in conjunction with your SQL database with something that you already have? So for example, let's say you have billions of rows in a SQL database, which makes the traditional search through that infeasible unless you're, I mean, you can use an inverted index and can text match and can hope that you get very few matches. But let's say if you want to do like a regular expression match over a billion objects, that's just not feasible, at least not if you want it in real time. So what vector search gives you is an opportunity to narrow that space down. So let's say you could run a expensive query such as regular expression, but only on a subset, and that subset you can determine that by vector search. And that's one of the things we were looking at. Okay, how can we, from a user's perspective, how can we easily plug that into a SQL database, basically, to have that nice workflow. And similarly to the sort of latency as the enabler of a use case. So if you look at, for example, a recommendation pipeline, I think traditionally recommendation pipelines, before you had live serving, they would have been done offline. So you would calculate for each user or each possible user, you would calculate their preferences and these kind of things. And then with vector search or generally with like live models, you can do it live. But still, like, even if you have this like complex pipeline of all these like custom trained models that take user behavior and take all the environmental things into consideration, you still need something to put in the beginning of the pipeline. And if you put a billion objects in that pipeline, then that pipeline is going to run forever again. But if you can narrow that down to maybe like the top 200, then that pipeline runs efficiently. And what is the piece of technology that narrows that down? That's vector search. You just do a search query to put that in the pipeline. Which is sort of part of scaling already. Like some things at scale simply make sense because you narrow it down with vector search first, and then for scaling vector search itself, I think this is where we see the big strength in approximate nearest neighbor models. So if you would do a brute search approach, then it would basically scale linearly. So if you have twice the data, it would take twice as long to search something. But because of approximate nearest neighbors model, so in Weaviate, for example, we use HNSW, but there's others. They scale much better. So basically, roughly logarithmically, like this exact thing depends on the parameters, but roughly you would see, and this is a good point to pitch our benchmarks that we recently released. So if you're wondering like what's the production performance of Weaviate, we have on our website maybe maybe Dimitri can include a link. We have a benchmark page, and there what you can see nicely is that a data set that's, for example, 10 million is not 10 times as slow as one that's 1 million, because it scales logarithmically. So you would see, maybe, I'm making this up now, for 10 times the data, you would maybe see 1.5 times the latency. And then basically you get that kind of scaling from within, because the data models scale very well in those databases.
Yeah, sounds great. And on Jina's side, like, you guys take a holistic approach to, the whole process of, playing with machine learning and deep learning and actually introducing my data sets and so on. So how do you view Jina's like role in that? And also, like, in general, do you consider yourself a player in vector search space, or is it not only that?
Yeah, that's a good question, actually. We found out that if we just give everything to the models, then they can also do anything. They are black boxes. So we should never trust the plain results coming out of these models. So we always have to combine them with traditional methods. So for instance, BM25, we'll also give later a talk about this, how we actually can combine these scores so that the results increasing some percentages and precision and recall.
Cool. This is a good segue to my next question. So this conference is sponsored by Open Source Connections, and they do a lot of search. So beyond machine learning, like, we have search applications of vector search, obviously, but many search scenarios today in the world are still running on sparse search. So like keywords, TF-IDF, BM25, what have you. So I was wondering, what do you think about what's going to happen in the future, or already happening today? How do you fuse these two approaches, vector search and sparse search? And maybe can you give some examples, or maybe some demos you guys built, where we can take a look at that? But in general, what's your feel? What will win, or maybe the combination will win? Are we moving into the hybrid search world?
You? Sorry. Sure. Happy to start. Yeah, I think this is a super interesting, because I think the honest answer is we don't know, because stuff is moving very, very fast. And right now, I think we have a lot of different approaches that sort of overcome the limitations of one. So, for example, you mentioned hybrid search, which I think everyone has a different definition of, but I'm just gonna, for maybe also for our audience, I'm just gonna define it for now as doing a vector embedding based search and doing like a BM25 or other sort of calculated or measured sparse search. And then combining the results in whatever kind of way. That could be doing one first, re-rank with the other, could be doing both independently, could be doing both independently at the same time. Doesn't matter. And I think, to me, this is like trying to overcome the limitations of typically vector embedding search, which doesn't work very well out of domain. And then out of domain, if you have like keyword matches, then a keyword-based search works really well. I think that is a very, very good strategy for now. But I also see that the models are improving very, very rapidly, and are especially improving out of domain. So I wouldn't be too surprised if at some point we just get a new release of a model, of an embedding model, that just sort of captures this space as well, does it so well that all of these hybrid workarounds, so to speak, that we're doing right now, that they just become obsolete, like with one new model release. So I'm kind of, yeah, that's kind of the future that I'm looking forward to.
Awesome. Yeah, Laura, you want to?
Yeah, so indeed a very interesting topic, and like where we end up, we will, like, it's a moving field. So I think we will never stop improving on that. And I think also what's really interesting is how this will look for like how this will look implementation wise, if we look at how to do this hybrid search. So do we like do a dense search first and then improve it with the sparse score results, the other way around? Do we like let the end user tweak it maybe? Do we train, maybe even train the model, like a new model based on user feedback on this? I think this is a whole new world to explore.
Yeah, and something else we should mention, I guess, is that we have so many different data types where we don't even have these sparse representations. So, for instance, when you do an image to audio search or something, and you don't have text annotations, then creating the vector representation and searching with this, like, the only possible choice we have currently.
Berlin Buzzwords Day 2. This was a packed day. I personally had a presentation on vector search. And here I have Alessandro Benedetti, who is the founder and CEO of Sease, a consulting search company. And I'm sure, Alessandro, you can talk more about it. And Alessandro is also a software engineer, actually, by trade, and deals a lot with information retrieval. And in this conference, you presented neural search in Solr, and I'm curious to learn more about it. But before that, how was the conference for you?
So I really like the conference. After COVID, it gave me the opportunity to meet people again and networking with like information retrieval specialists. That's amazing. I mean, I'm really passionate. So having the possibility of meeting people and discussing with them, it was a pleasure.
And especially, I can agree that it's quite great to meet in person finally after 2 years of completely virtual, although this conference was also hybrid. So some of the speakers were presenting online, like Max Irvin, I know one, and some people joined as participants online. So it's still hybrid, but it's amazing to meet people in person and amazing the vibe, you know, to see everyone. So I'm really happy about that. And yeah, of course, Vector Podcast is about vector search, but also vector as a direction in your profession. And so I think you've been consistently following the vector of search and information retrieval at large. But also recently you picked up neural search and you introduced that functionality in Apache Solr, I believe, with your colleagues at Sease. Can you talk a bit more about it? Almost like a recap. And of course, there will be a talk recording so our listeners can listen and watch it in more detail later.
Absolutely. So first of all, the contribution was born out of curiosity. So I was like, I'm always been very passionate about integrating machine learning and artificial intelligence in general with search. And we started initially with some training. So we were, first of all, learning ourselves how you could integrate artificial intelligence with search, then language modeling, vectorization, and vector-based search. And then after we reached the point we were able to run a training on that topic, can we actually improve what's currently available in the open source community? So it was at the beginning. So initially, when we approached the problem was more or less, I would say, May of last year, so 2021. And there was some work going on in Lucene at the time. It was still probably not mature enough to be ported to Elasticsearch and Solr at the time. I'm a Lucene and Solr committer, so my main focus was to bring it to Solr. So I waited a little bit. I was investigating available plugins, such as your plugin, for example, Max Irwin work. And I was like, well, I mean, that's very cool ideas, but using like some native kind of data structure would bring like a new life to Solr. I mean, it would probably bring like new experts contributing. So I really wanted to try to contribute something native. So around November last year, so 2021, I ended up thinking that Lucene was mature enough to effectively do the porting to Solr. So we explored the implementation, the Lucene implementation, which is based on hierarchical navigable small world graph. At the time, it was just navigable small world graph, so there was not the H of hierarchy yet, but that's been introduced lately. And we thought, okay, this is mature enough, so we can implement this in Solr. And the idea was to keep it as simple as possible from the Solr perspective. And we wanted to start with the very basic steps. So giving the possibility to people to index vectors and search vectors. So that was the minimum we wanted to give. So for that reason, we started working on how we could implement the KNN vector field type from Lucene to a field type in Solr, so that you could possibly configure in the Solr schema a field to be vector with behind the scenes, the hierarchical navigable word graph implementation in the index. So that was the first part of the integration. And we ended up with like a complex way of pushing data to Solr. So you had like to push data in like a custom way rather than a normal JSON array. So the first prototype, we were not fully convinced it was fine. I mean, yeah, it was not that bad, but people had to learn a way to model vectors that was like custom to Solr. And we were like, no, maybe we can improve that. So at that point, we did some research and we ended up finding that with some customization, we could use float arrays from Lucene to model the data in a comfortable way. So you could just push a JSON with a classic JSON array of floats. So that would be probably the easiest for a newcomer to just push data to Solr, because intuitively you could expect, yeah, I can just push a vector in as a float array. So we extended that class, we implemented it in Solr, both for indexing, so when you push your documents to Solr, and in retrieval, so when you get back documents from Solr, and it looked quite nice. It was like, okay, we don't need any additional custom code to parse it. We can just use straight ahead JSON arrays, or potentially, of course, XML like multi-valued or lists in Java, but it was like quite straightforward. So user didn't have to learn a new way of representing vectors that was proprietary to Solr. So that was the first step. Brilliant. It was working fine enough. Indexing perspective was super simple. You define the vector in your schema as a defined field type. You define the dimension. So you specify that's fixed for a field, and the distance. So you need to decide the distance at indexing time, because that distance affects the way the hierarchical navigable word graph is implemented. At that point, what we did was, let's take a look to the distances available in Lucene, and Euclidean, cosine, and a simplified version of cosine. Specifically, if you have your vectors that are already normalized, you effectively avoid the normalization in the cosine distance, and you can just use the dot product. So that's like to speed up performances. So in case you're able to provide vectors that are unit vectors, you can leverage the dot product distance in Lucene, in Solr, to speed up your processing, building time, and query time. Building time was solved. So we were using HNSW for building the graphs and indexing time. We were using stored field of float values for the retrieval and pushing of data to Solr, and it was working. It was building the index. The index was correctly memory mapped in Solr to speed it up and load it in memory. So it was now the time of checking the query time. So from the query time perspective, what we did was, again, we want to make it as easy as possible. So Solr has a mechanism called query parsing. So it's a component that have different implementations according to your requirements that give you the possibility of parsing a user query and building a Lucene internal query. There is in Lucene the KNN query. So we were, okay, let's build a very simple KNN query parser. So the user will just send an input, a query vector, a field, and the top K. So I don't know, I'm interested in the default top 10 or top 100, whatever. So very simple, no fancy, like difficult parameters, very usable to like even a newbie that has not a lot of knowledge of vector search. That was quite straightforward. We decided to implement the query vector as an array. So from like the syntax perspective is square brackets and comma separated list of floats. So pretty standard in Java, Python, and anyway, when you model like arrays of values, it's actually quite used. And that was it. It was like time of benchmarking. So let's see, it is working fast enough to be usable. So for that, we started with a preliminary test. So We haven't yet benchmarked like trillions of documents. We have not done that yet, but we worked on a couple of gigabytes of index, comparing it with like lexical search, and it was like fast enough. The indexing time was like twice as low, but anyway, that was expected because there was the necessity of building the graphs, and of course, building the graph is expensive. There are some parameters that you can tune to make it faster, but anyway, it was like, okay, indexing time is doable. It's fine. It's not like a barrier for using it in a production environment. And query time, surprisingly, was actually in that scenario even faster than the equivalent lexical search. So we were like, okay, I mean, that's great. It's approximate, of course, because it's approximate nearest neighbor, but it was fast enough. So we were like very happy. And we tried optimize segments because anyway, so there's a specific codec for hierarchical navigable small-world graph in Lucene, but leverage is pretty much the same approach of Lucene. So you have multiple segments, they must be scanned and results aggregated. So we wanted to check what happens if we merge segments. So we keep just one segment, the graph all in there. Is it bringing any benefit? We were expecting some benefit. We didn't know how much. And that surprisingly offered more benefits. So we did the same for the lexical search. So measure the segments and compared how is it behaving, the same query in the lexical form, so just query terms, compared to the same query encoded as a vector. And surprisingly, the benefit we got from merging the segments for the vector-based search was twice as good than the benefits that the lexical search got. So we reached the point we were really happy. So finalize the contribution review by the Lucene and Solr community. So we got help from Sokolov, Christine Persk, and Cassandra Target from the documentation. So it's been anyway, I mean, mainly the development has been myself and a colleague of mine, Elia Porciani. But then we got the feedback from the community that has been really, really valuable because especially for the documentation. I'm not a native speaker in English, so I had the necessity of some help to fine tune some of the areas. And that's the story of the contribution. And then was merged in approximately March, and in May 2022 was released with Solr 9.0.
That's a great story, and congratulations on that release, because I think Apache Solr, compared to say other projects which are also open source, it has very big community, right? And like also committers, and you really need to follow all the sort of like protocol in a way, like with all the feedback and votes and so on. So I mean, it takes a lot of effort, I think, to merge it, and it also influences so many people, so many users. So really congratulations on that. And this is great work. So I think just as a former user of Solr, I use Solr since 2010 and for about 10 years or more. We always kind of thought it from the perspective, okay, we have a running search application, and let's say it could be lexical search. Now we want to toy with neural search. So would I be, as a user, be able to atomically update my existing documents with vector fields, or would I need to sort of like reindex something from scratch? Did you see such scenarios? And maybe what other like limitations or pitfalls you see, or maybe possibilities you introduced that you can talk to?
So that's a great question, because currently atomic updating Solr documents is a problem that's not solved 100%. So even considering like textual data or numerical data, so without taking into account vectors, it's still not a fully solved problem. At the moment, if you introduce like vector data, you would need to reindex, and it's not ideal. So we want to improve that, and especially because a lot of companies may have a lexical index and they just want to update with the vector-based index. It is doable because there are separate codecs, so separate files on the disk, and it's one of our priorities. It's not there yet, but going on with like the pitfalls, there are some other areas we want actually to improve. So that's one, definitely working into improving the atomic updates perspective. The second improvements we want to bring is related with pre-filtering and post-filtering. So currently, the Solr 9.0 version implements filtering as post filters. And post filters are not ideal in a KNN search because you may end up having 0 results. Potentially you post filter all of the neighbors you initially found. Luckily enough, it's a problem that has been solved in Lucene a couple of months ago. So using effectively a bitwise comparison between the live documents or documents coming from a filter or filter queries, you can effectively check if the neighbors is to be accepted or not when you calculate the top K. So these improvements have been merged with Lucene 9.1 and are coming with Solr 9.1. So we are working in that direction. We have pretty much finished the contribution. We just need to merge it. And we expect Solr 9.1 to come out probably in the next couple of months, something like that. And we will have pre-filters. So at that point, filter queries will pre-filter your documents, and then you will have your top K, KNN search that will return your K neighbors. Another aspect that can definitely be improved is re-ranking. So right now, it's not working as just a rescore, exact distance with your query vector for your documents. But ideally, what you want is you just run a first pass retrieval of top K, and then you rescore using the distance of your preference at query time, the query vector with your document vector. So that's currently not possible. It does an intersection between the results of the neighbors and the original top K first pass retrieval. So you may end up having some of the documents from the first stage retrieval not re-ranked effectively. So with just the original score. On the other hand, some of them will be rescored, the one intersecting the neighbors, and will got the boost and go up in the ranking. So it's usable, but I would say with care. I would wait probably for Solr 9.1 and using it with pure rescoring, so you just get the distance, the brute force distance in the top K. And then the final limitation I see currently is multi-valued. So it's not only a limitation of Solr, it's a limitation of many vector-based search engines, but it's a limitation nonetheless. So you still need to work with single value documents. Many solutions, of course, you can split your documents based on maybe sentences and then aggregate them again after that. Effectively merging the documents in a single unit of information. So I think it's pretty much similar to some fusion algorithms that are used in the distributed search as well. Still, I would love to see multi-value supported natively in Lucene and then consequentially in Solr. I'm working on that. Not exposing that much because I'm not yet sure if it's going to make sense fully, the solution I'm building, because it's like there are a lot of areas in Lucene you need to change. So I have a prototype that works end to end, but is not measured enough to effectively bring it like to the community. So I will work on this another couple of months maybe, and then hopefully you will see a pull request.
Yeah. This is great so far, insights from you, and also like it shows the power of open search, or like open source, excuse me, like where you really can like collaborate or cook something up, and even if you are not sure about its future, you can still share it with the community. And I mean, this is amazing. This is the power of open code in many ways. I wanted to still answer you on the possibilities side. I think in your talk you presented that you played with BERT model, right? Basically, kind of extending the idea or the promise of vector search in the semantic space, right? So basically, understanding your query, and of course, we also gave examples in our presentation where, for example, keyword search may focus only on specific keywords and forget that there is a main object or subject that you are actually focusing on, like a bear eating fish in the river. It brings heron instead of the bear. And so BERT models should be able to solve such things. So can you open up a little bit like on use cases that you've seen maybe in your practice, or maybe what you've been actually toying with when you implemented, because you needed to test your plugin, right, end to end, and see how it works? And maybe a little bit, can you touch on the future? For example, are you planning to try other models like Clip, going multimodal, or something else that might actually, as you said, bring even more life into Solr and community to show the power of vector search?
That's a great question. And the initial necessity was more driven by curiosity, personal curiosity, I would say, and some, from a certain perspective, some curiosity from our clients as well, but mostly personal, because what I noticed, and in general we noticed as a company, is that clients are generally, at least the kind of clients we have, not really ready to approach search through like neural search, mostly because they don't have a curated data set to fine tune the models. So we know that nowadays it's pretty simple to find a pre-trained model. There are like many different language models, many different like benchmarks and data available, for example, big data sets such as MS Marco that offers the possibility of testing your model. So there's plenty of language models around, pre-trained on Wikipedia, pre-trained on the web, pre-trained on large bibliographic data, and they are quite accessible. But on the other end, fine-tuning them, it's something you shouldn't like keep it as a trivial thing. It's not trivial. It's really heavy as a task, especially because you need to build your ground truth. You need to build your label data, and that's something that's still missing. So for that reason, many of the companies we are working for, they are still subject to like the vocabulary mismatch problem. So they currently tend to solve these using like curated synonyms, knowledge bases, potentially integrated with like external knowledge bases, and potentially using natural language processing to solve entity linking problems and identifying topics. So techniques that are a little bit different from like language modeling, but that potentially don't require like the same amount of label data. So I would say that our hope introducing vector-based search in Solr was, first of all, enabling companies to have something to use, because at that point, you may spend more time building your label data, because maybe you've been using Solr for the last 5 years, and not many companies have the expertise of migrating to new search engines. So potentially, they were interested in vector-based search, but they didn't have the traction, the momentum to build their label data set and fine-tune models. So now that it's going to be available from Solr 9.0, maybe you just need to upgrade your Solr. So maybe it's not that much of a deal. You can pass from Solr 8 whatever to 9, and at that point you have vector-based search. So what I hope is that companies are going to start experimenting and labeling their data, and maybe initially just using pre-trained models, which it's not ideal. I mean, if your corpus of data is closer to the original corpus of data, maybe you can get something good out of it. But generally, I wouldn't go live with a pre-trained only model. But with this accessibility now, I hope people will start building more label data and fine-tune the model. And then making like the effort of also bringing back to the community what they realized could improve the system and spread even more these new approaches. So from the perspective of multimodal and multi-language is something that we haven't explored yet. I attended your talk today, brilliant. So it's something I would love to explore because so far effectively, the only approach we had in a multi-language was through entity recognition and linking and aliasing effectively. So being able to recognize entities and then search across the different aliases in different languages, which is a completely different approach from language modeling. So it's something we haven't explored yet. We want to, and from easy to ease this part, we are working in the direction of integrating language models with Solr even better. So at the moment, what you need to do, you need to effectively use externally from Solr your language model, extract your vectors, integrate them in Solr. At query time, extract the vector from your query, and again, run your vector-based search, KNN search in Solr. So what we love would be to effectively ease this process and do that internally in Solr. How? From the indexing perspective, there is a component in Solr called update request processor, which has many different implementations. And the responsibility of this component is when you process a document during the indexing phase, you can enrich the document, you can manipulate the document, and potentially add new fields. So that's a perfect fit for an update request processor that takes in input a language model, and at indexing time, when you process your document, you run the inference potentially locally, or potentially you may call a service like Mighty from Max. And at indexing time, you directly enrich your documents. So the Solr user, aside from the configuration in the Solr config XML, which potentially is just literally the path to a file or the URL to a service, you don't even need to know that's neural search, right? I mean, you just care that it's text and it's encoded in some way that Solr will then give you more relevant results. At query time, we want to introduce a query parser that will do the same. So it takes in input text, it takes in input again, like a model for inference or a service for inference, encode the vectors, the vector or vectors, depending on how you model the free text in your query, and run KNN. So in this way, everything will be transparent to the users. And again, this is another enabler. So at that point, many more companies, many more individuals will be able to use it. And what we hope is to then see many more contributions, improvements, both functional and from performance. And in general, of course, like a new golden age for Solr. That's the ultimate goal from a Lucene and Solr perspective as a committer.
Thank you so much, Alessandro. This was very deep on Solr. And by the way, I have to say that, first of all, there is a new episode with Max that was released just today, talking 2 hours about Mighty and economics of embeddings. And second, but not least, is that I'm really happy that Apache Solr turned into also a neural search engine, predominant in a way, right? And so this is great. It's also battle-proven search engine, right? It's used in so many companies, and so I anticipate a lot of use cases coming from that stream of user base. And hopefully there will also be contributions, as it has been happening with introduction of, for example, learning to rank plugin and so on. This is all great, and I'm really excited that we see a neural search. I don't want to say commoditized, but it's kind of like really reaching all angles and sort of sides of search world. And of course, neural search has a lot more use cases, for example, object classification and so on. But I'm a proponent, I'm an adept of search and information retrieval, and I'm really happy that we have finally merged the deep learning with, the use cases of search, and they really align together. Like you've been showing, and we've been showing some demos as well. I would like to finish our conversation with my favorite question, which is this magical question of why. You've spent a lot of time in information retrieval, both academically as well as industrially, and now running your company for several years. I'm always curious, what continues to drive you to stay in this space? Of course, this question is pretty much answered by your activity in neural search. You picked up the implementation, and that says for itself, your curiosity, you said it already. But is there something else that continues to drive you? Wake up and then say, yes, I want to continue working on search. And also you impress your colleagues and you inspire your colleagues because you are the CEO of the company. So you have a different perspective there also to keep them engaged and motivated, which is also very important for your company.
First of all, I am a science passionate. So for me, the pursuit of knowledge through the scientific methods drove my entire life. So since I was a kid, I was a math passionate. Then high school became also a physics passionate, and then computers came in and in my household. So I was like, whoa, that's something quite cool because it's like math and physics embodied in a something like that's pure math and physics. And I was impressed, and I fell in love with computers. And originally, just as a young kid, so I was exploring it. But then, growing up, high school, university, I choose computer science, and my pursuit of knowledge reached the point that I learned about information retrieval, a science that aimed to get knowledge out of a corpus and satisfy user information need. And it was like, that's perfect because I want to seek knowledge, and this is an automatic system leveraging science to increasingly get knowledge. And it's a sort of meta kind of passion because it's effectively a tool to obtain more knowledge, and now I'm working to improve that tool. But it was love at first sight, to be honest. And over time, artificial intelligence came in. Actually, I mean, to be honest, has been there for a long time, but springs and winters over the last 50 years, more or less. But luckily enough, we are living in another spring for artificial intelligence. And again, like artificial intelligence and machine learning, actually, which we have currently, is again a sort of embodiment of pure science. So a sort of entity which ideally you will build based on the most solid principles which I follow as a human, because I'm again really passionate about that. And being able to leverage those new techniques to improve information retrieval was increasingly exciting to me. So that's the reason I'm keeping more excited and more excited with the days passing, because now it's, in my opinion, like a great time to live for computer science in general, and specifically information retrieval plus artificial intelligence. And because of that, I also want to share this knowledge. So that's the reason I actually contribute to the open source community. I contribute to conferences. I go to conferences and speak. And there, I share this passion with my colleagues. I encourage them to do contribution. I encourage them to go to conferences with me, alone, whatever, because what I really want from my company is to ease the process of bringing new ideas from academia and in general from research and development to the real world, to the industry, to applications that can improve human lives and our lives. And using open source software, to me, is also the best way to do that, because we, as humans, we want to stand on the shoulders of giants, as normally we say, right? So we don't want to reinvent the wheel every time. We want to actually improve the wheel and slowly iterate and bring like a better wheel, a better item that will provide the same functionality, maybe in a more clever way. And that's the way I also pour my passion towards Lucene and Solr, and in general, I mean, open source software, and I drive my colleagues to do the same.
Yes, I see a lot of drive in you, and thanks for doing this. Also, thanks for presenting. I know that one of your colleagues was also presenting today. Can you say her name?
Yeah, Daniele Antuzzi and Ilaria Petreti, they presented about word-to-vec integration with Apache Lucene for automatic synonym generation, which again is like a different view on pretty much the similar problem of effectively that language models are solving. Word2Vec is like a sort of, let's call it a primitive language model to a certain perspective. So our plans are also to actually integrate like automatic synonyms generation potentially through like large language models, but it's a first step. So at the moment in Lucene, you just need to provide a text file with manual curated synonyms. So having the possibility of reading the index, estimate vectors, and returning automatically the top synonyms for the term, in my opinion, is already like a really nice enabler to, again, like let people experiment. Yeah. So they did the talk today, and it's going to be available among the other Berlin Buzzword talks probably in the next month or something.
Yeah. Awesome, awesome, and thanks so much, Alessandro, for your time today. Picking up, of course, we are all a little bit tired after 2 days of conference, but at the same time energized, and we have so many thoughts. So thanks so much for recording with me. Thanks for answering that deep, the why question, which I enjoy asking, not to actually tease or provoke somebody, but more like to actually drill into how they think about their role or the search world in general. So thank you very much. Good luck in your future projects. Good luck with the next release of Apache Solr with improvements that you mentioned. And I'll see you around. And Berlin is waiting as well. So yeah, let's enjoy it. Thanks so much.
Thank you. Thank you, Dimitri. It's been a pleasure for me to being able to talk with you today.
Yeah, thank you very much.